You're live, it says. Howdy. I'm Ryan, the calculus tutor. This is after school homework help. Let's get the screen shared. Cool. If you'd like to participate, if you'd like to get your question answered, if you'd like to use this service, you can go to calculustutor.com. You'll scroll down just a little bit. There's a submit your question button. We'll go through that actually in just a moment. I'm going to let us get started, let people submit questions, that sort of thing. I'm going to check for submissions. Back end. There we go. Okay, nothing yet. I'm going to you're going to see where my hair drips. I'm going to go. Oh my god, it dripped on both sides. Well, that will have to dry, won't it? The stream's about to get started. Submit your questions. I'll look for questions when I get back. I'm gonna mute up uh, and turn the camera off for a moment and be back in just a couple minutes. So submit your questions. I'll get back. We'll go through the process just for anybody that wanted somebody to walk them through it, and then we'll answer questions. Back in a moment. Howdy, howdy. We are back, it looks like. Let's get this stuff up and going. Oh, wait, no. Oh, there we go. Oh, there we go. Sorry you can hear the click so much of my mouse. Sorry you can hear the click. Sorry, I realized you'd probably also be able to hear me playing the stream on delay. Ugh. Hi, welcome to the Wednesday stream. If you have a math question you would like me an answer to, that's what I do. Hi. So what you can do, if my computer will respond. Sorry, streaming sort of bogs down my computer a little bit. Let me make sure. Yeah, that's frustrating. Okay. You go to thecalculustutor.com. That's that right there. And you can see there's the stream right there. There's a there is a submit a, there we go, a submit a question button you can click on. I'll take you to the actual stream page. So you can watch the stream right there, but that's just sort of the home page of the whole site. This is the stream page. Scrolls down to the submit homework problem section. There's a homework submission form. I recommend you go there. It might bring this up before you see this. It might ask you to sign into your Google account. You have to sign into a Google account to access the form because you can submit files. And submitting files means you can submit pictures of your questions. And I think that's really important. So this is the form. Please sign in. If after you sign in, if you use like your school Google account, your school might have your Google accounts set up in such a way that you can't access my form. I don't think that's going to be the case, but if it is, if you sign in and it says you can't access it, you could try to just sign out and sign in. If you have a personal Google account, you're fine using. You can use that. Or you can send your question via email to ryan@thecalculustutor.com. And that there's guidance about that back on the page we were just on, and I'll show you that in just a moment. Oh wait, you weren't seeing the form. Ugh, I wasn't paying attention to the stream. There you go. So back on the page that just disappeared, there's guidance on that, but we'll go through it in just a moment. Hopefully you should be able to access the form, no problem. Please let me know if it does give you trouble. There's a box to check to say, yeah, this is my email address. You can include it. And then tell me who you are. That's just how you would prefer me to refer to you while I'm answering your question. I'll say, oh, here's a question from such and such. That way, I'm answering your question. So what name would you like me to use? You can include your pronouns here if you care. Otherwise, I'll probably just use they. Tell me where the question came from. By that, I mean what class and teacher. This is mostly to help me organize solutions and question answers and stuff like that. So you know, Mix Jacobson's geostats, uh, Mr. Smith's Algebra 1. Simple as that. If it's not from a class, if it's just from your life or from your job or whatever, just briefly, very briefly describe it, a full sentence max. So the point of that's just to help me organize and understand your context a little bit, not to be something to get in your way. So put something in there and then just breeze right past it. Two, the most important part, the what is your question, right? So this is where you can input your question. Oh, you can see it already had something filled in for me. The key here when you ask your question is to be as specific as possible. Um, so yeah, you tell me number 10, and then down here you could go down and you can attach files, images, and you could attach a picture of number 10, and that would be great. But what would be even better, and it'll help me give you a better answer, is if you tell me what about number 10 was giving you trouble. You know, so you could say something along the lines of uh, parts A and B, oops, just letter B, were fine, but the um the graphing in part C uh is hard or whatever. Right, so you're like, if it's a specific part of a problem, um direct me to which part. That doesn't necessarily mean I won't go through parts A and B, especially if they feel relevant to part C, but it does mean when I get to part C, I'll know it's specifically the graphing that tripped you up there. um and so I can focus on that and the strategies around it. But maybe it's not that specific, right? It could totally be something like these problems aren't, oops, like the ones we did in class. There you go. If you just don't know even what you're supposed to do, so you could say that instead. You're like, I'm not even sure what I'm supposed to do here. That uh that is actually specific in the way I'm talking about here. That just lets me know where you're getting tripped up. And if getting started is where you're getting tripped up, I can help with that. Um a problem like this actually illustrates something that will be really helpful. So, in addition to describing your problem, and so you don't have to retype the whole math problem here, that's not my goal. There's just a place for you to attach an image of it. If it's a worksheet, if it's a problem in a textbook, take a picture of it and attach it, which means it might be best to do this form on your phone. And you just go to thecalculustutor.com, submit a problem, go to the form, boom, and do it right on your phone. And that way you can just attach it right from your photo reel. So in addition to including a picture of number 10, well, actually, let's talk about the images and then we'll go back to that. So include a picture of problem number 10. The thing to think about here is to be clear and complete, right? So clear just means I can read it. The text isn't too small or too blurry. If you take the picture and the text is blurry, just retake it really quick. And I'll do my best to parse through it. If it's a little bit blurry, that'll probably be fine. If I can't tell if something's a 3 or an 8, hopefully you're in chat and you can clarify. If you're not in chat right at the moment, that's totally fine. I'll just make a call on it and say, well, I'm going to assume this is an 8 and we'll move forward. And if it was actually a 3, well, then that presents you with a good opportunity to practice, to use what I did with different numbers, but it should still work out the same, just you will get different numbers as a result. You can then always follow up and send me a picture of your work with doing it with, say, the correct value and ask and have me check it for correctness. I would totally check a problem for correctness. And that actually gets to a really important part here. So the complete part, the clear part is important so I can read the problem, but I'll do my best. The complete means, first, don't crop out part of number 10, whatever number 10 is. Make sure it's totally in the picture. Also, make sure any additional instructions, sometimes in a worksheet or in a textbook or whatever, there's like a block of instructions and then all the problems. Make sure that block of instructions is either visible in your picture or take another picture, a separate picture of it, and include that as well. And then any pictures or diagrams, including like if there's like a number line or a coordinate axis that you're expected to graph on, include that. Even though it's blank, include it. And when I go through the problem, I will actually do the problem on the same thing you're supposed to do it on. That way, you can sort of see what your teacher is likely expecting. And then that does get us to the last thing, especially with like when you say something like when the issue is like you're being asked to do problems you feel like you haven't been exposed to in class, you haven't been taught how to do them. Sending me pictures of your work or your notes or anything like that. So you say these problems aren't like the ones we did in class. Send me a picture of the problems you did in class, right? Like from your note, like if you were following along in class and you maybe even felt like you sort of got it, send me a picture of that. And that way, when I'm looking at in addition to the picture of the problem, I can sort of see, oh yeah, these aren't the same at all, or oh, these actually are the same, but the textbook for whatever reason has them formatted differently, or it just has them set up differently, but it's like the same skill, and I can help you translate between what happened in class and what's happening in your textbook. Yeah. And then same thing, attaching I would love it if I did a problem and, you from that did more problems and then you sent a follow-up that's like, okay, I did some more of those problems. Can you check my work? I would totally check work on here. I should probably add that to the website as an option here. Like, do you want me to check your homework? Now, here's what's really important. I can totally understand. I'm saying that you might be hearing check your work like on stream, and that might like fill you with dread, and I would totally get it. I think it would fill me with dread too. So here's my promise to you. I'm not going to show your work on stream unless you check this box right here. If you check that box when you submit this, then that tells me so especially if you want me to like check your work, not only are you cool with me going through, because to check your work on stream, I would have to say, okay, such and such, I'm checking your work, number blah blah, this looks good, number blah, this looks good. Oh, on this one, let's talk about this little point here, and I would do all of that without actually showing any of your work. I might rewrite or to summarize to the audience sort of what your work showed to use it to teach, but I would not show your work unless you check that box. And that can be really helpful when checking work. I imagine that might be more appealing to like older students where the problems are a little bit longer and there's more work to check. But like if you just have a whole homework assignment, seriously, I would right now at least things are slow. So I would totally be willing to check your answers. And if you want me to do that without actually exposing your work to the stream, I totally get that. Just don't check that box. If you submit a question, so that's how you submit a question. Let's go back to the site. If for whatever reason that form's not accessible, or you need to send me more than 5 pictures because you can only attach up to 5 files, then you might want to email me, ryan@thecalculustutor.com. Or if you want to also send me links. Another thing about the form, not only can you attach images, but you can also attach PDF files. So like if you have like a packet on Canvas or whatever that's actually just a PDF, just download that and attach that whole thing. That means you have to be even more specific in that text box where you tell me when you describe your problem, direct me to the correct place in that PDF packet. But like, if you send me extra practice problems, those I will probably end up doing some of those on stream, just in between questions and stuff. No guarantee, I might. So like, if you send me extra, it may not go to waste. That's the process. Oh, right here, if you're gonna send it via email, because the email is open-ended, instead of having like boxes that are do this, do this, do this, here's just something to help guide you through it. Make sure you include your name, and that's just preferred name, your pronouns if you care. Problem source, what teacher in class or where in your life you encountered this problem. your specific question, just like we talked about before, being as, and one, maybe two sentences. Like, don't let this be a burden. I don't want submitting a question to itself be burdensome. I want to try to make it as easy as possible. It'll probably feel a little clunky at first, but I'm hoping some students will sort of use it on not necessarily a frequent, but maybe a frequent, but at least a regular basis, and start to get sort of a real, just get the process down right. It just becomes super easy to take a picture, go to the forum, attach it, describe their question, send it off to Ryan. Cool, I'll watch the VOD later tonight or something like that. Because that's the other thing. You don't have to tune into the live stream for this to be helpful. So yeah, ask your question, attach your clear and complete images, possibly including images of your work. Um, if you don't say whether or not it's okay for me to show your work on stream, and you do send me a picture of your work via email, I will assume you don't want me to. So my assumption is people don't want me to. I will only ever do it if people explicitly tell me it's okay with their work for that particular submission. Doesn't carry over. If I happen to recognize, oh, this person sent me a question before, oh, last time they were okay with me showing their work, I won't assume it's true next time either. Okay, that's submitting a question. That's what we do here. Let's go back to the. Oh, actually, really quick, I will show you. Oh, I have to hit the button. And come on. Okay. Well, yep, there goes. The notes, when I'm going through a problem, it's gonna fall. The screen's gonna follow along with me and where I'm at, right? Um, and you might want to look back at a previous step, or you just might need to check something. Um, so you can access the notes, and scroll all around them and go to whatever parts you want. Um, and there's a button right here. Go to notes. Boom. You click on that. It'll open up the notes for you in a read only setting. So you can look all around. I think you can grab stuff and copy it. Um, so you can paste it elsewhere and stuff like that. And you can definitely like take screenshots of it and stuff if you want to paste it elsewhere or save it. Um, these boards, Miro boards, my plan is to make them kind of always available. I'll have an archive, especially once I get like actual content in there of answering people's questions. Some of this early stuff that I'm doing during these early days as sort of sample content and filler and all that sort of stuff. I have no intention of preserving all of that. Yeah, this is all just practice right now. But as people start to be aware of this service, take advantage of it, I start to get actual submissions. Um, all of those question answers they should continue to be available and archived on YouTube, on the website, things like that. So that's the plan. Including the notes. I guess that was my point. All of these notes will be available. Um, and then also on the stream page as well. So this pink box here is basically like the stream box. It disappears when I'm not streaming. It appears when I am streaming. And then boom, notes. So yeah, so follow along on the notes or access them anytime. So this is the notes file that's currently active, and then older ones, as they end up having real content, will be made available in some sort of archive. Still working on that. So let's go back to the notes. Okay. Of course. Oh, Stream starting soon. Stream is started now. Um, so yeah, so you can go to that, you can press that button and you can go back and look through all of the notes and see what's happened on each day. As things hot, look, there's uh, a little thing for me to grab for when I'm stepping away. Bring that over here. That seems like it'll be useful. But yeah, you can scroll all around, see those sort of artifacts if you want. Um, the plan, I think these will end up being weekly once there's multiple questions a day. But for now, I'm doing multiple weeks in a single one, just to make that management easier. Let's check again for question submissions. Always want to keep an eye on the inboxes. No, let's see. Looks like none through the form. Okay. No question submissions as of now. Last night was the Tuesday night stream. Kind of want to potentially make Thursday a night stream as well. I'm still thinking about that. So during the stream last night, I started going through questions from the OpenStax, which is an open source textbook and educational resources site. The OpenStax calculus textbook, volume 1. There's 3 volumes, and was sort of thinking a potentially useful ongoing piece of this, on slow days or in between questions and stuff, is I might just answer OpenStax exercise questions, the even ones, because the odd ones already have not solutions, but at least correct answers provided. Um, Along with, there's also these checkpoint questions throughout, but those also have not solutions, but answers provided, and they're almost always alongside an example with a full solution, um, for the same type of question. So initially, I was thinking of going through and answering literally every question, but since all the checkpoints and the odd ones already have at least correct answers for students to check their work on, my thinking was I could do the even ones and provide full solutions to those ones. Um, and then if people want me to, I can do full solutions to select even problems as well. So that's one idea. So that's one of the things we'll talk about here today is ideas for the stream, capitalized apparently, and the channel. That too. I mean, I can do other things, and I plan to clip out bits of this. For things like shorts, or even honestly, some of the explanations aren't good shorts. They're 5-10 minute YouTube videos, right? So I can just clip out sections of the stream and have have some content to post. So, ideas for things that I can do. Ideas for the stream and channel. Um, right. So we have OpenStax, calculus, um, textbooks. This is solutions to even or odd problems to now I don't remember if it's the evens or the odds. I've gotten myself confused. Um oh, hold on. I think we can just look yesterday. What did I work on? I worked on number 2. Um solutions to even numbered exercises. Okay. That's one idea. And I like doing that. I like working on calculus problems. I just find it fun. It is a it is not a hard or challenging way for me to spend time. I mean, it's challenging in that like satisfying way, like video games and puzzles are challenging. Board games, that sort of thing. It's like it's a play challenge, right? Okay. I I've had some other ideas though. I've mentioned this in a previous one. So 4J is moving forward with the governor's cell phone ban mandate, which is not terribly surprising, even though it is disappointing. Um, I want to uh, pull and track the disciplinary data as that goes into effect. So, pull, track, analyze, 4J disciplinary data. This is cell phone ban goes into effect January. So after the winter break. Look at last 10 years. Cell phones have been some sort of issue basically since I've been in high school. I mean, students, when I graduated from high school, I had a cell phone, I believe. But like when I was a freshman, I did not. So that like it happened right as I was in high school. And then it's continued to proliferate since, right? More students have had more powerful cell phones every single year. Um, so yeah, I would like to look at that disciplinary data, look at it in recent history, and look how it changes as we go as they take on this new disciplinary endeavor. And it's a ban, so it is a disciplinary endeavor. It's not. They hope for good outcomes. They hope for positive, uh, growth outcomes, but they are pursuing those with a disciplinary measure. Um, I don't know. I What I was taught was that actually tends to not work great in the long term. Okay, what else? Oh, I want to look at um the mathematics of AI. AI, modern AI, is a math hack. So we should look at that. We can understand that math hack. Um, there would be learning here for me too. I mean, in the tracking the disciplinary data, there would be learning there for me as well. That's like literally the thing we're doing is like, let's look at the data and see what we can learn. The calculus textbook thing, I mean, there would be some learning there for me too, in terms of part of why I want to do it is I'm curious about that textbook. I've used it a ton for reference, but I've never actually gone through it. And so this is a little bit I'd like to learn about that textbook, being an open source textbook. Um, okay, those are some of the ideas right now. And then there's always just the other fun math stuff, like we did. Um, I did a whole stream, I don't know, last week, uh, about using Desmos to simulate the various like astrological cycle and astrological astronomical but kind of astrological, honestly, to use it to simulate or model the astronomical cycles of a fantasy world. Like I'm working on a tabletop RPG, both world and system, and uh, it occurred to me that I could have fully simulated uh, astronomical and therefore within the fantasy of the world astrological um, cycles in the world, and I could use Desmos as a tool, at least to get started, to actually to simulate it, or to model it, and then I could, from there pull out the useful relevant data, dates of full moons and new moons, and yeah, and so what we did is we modeled, to as like a proof of concept, we set up an equation that modeled the lunar cycle, our moon's actual cycle of new moon, to waxing to full to waning and back to new, and looking at that and using it, setting up an equation based on what we know about our moon. So we looked up the actual lengths of those cycles and things like that, and use that to predict when the full moons of this year should be, the ones that have actually happened and the ones that will happen. And we do this all the time. And almanacs have this sort of, we've known how to predict this sort of, like, you can just watch the moon and keep track overnight, over many nights, over the course of a year, that sort of stuff, and notice that there's a pattern. And humans did this. uh I mean, we don't know how far. I mean, we've been able to see the moon the whole time, right? So, and we've since we've been humans, part of what makes us human is that pattern recognition, that ability to then utilize that to make predictions about the world that tend to be right more often, or often enough that it creates like a survival mechanism for us, right? We're right often enough that we get a little bit of an edge. We don't have to be right all the time, and we're not right all the time. Um, we're just right often enough. So those are some of the things I'm thinking about doing. Um, the mathematics of AI. This is largely this is like what's called linear algebra, matrices and vectors and things like that. And then if we get into AI and things, tensors and um yeah. And so I'd be curious where to start with that. I would probably look some stuff up, but I could just do that on stream and find some places to start, and then we can find something to explore and then sort of extrapolate out. I am sort of interested, and I don't know how feasible this is. So maybe I'll make a note here. Um, Mini AI, right? So my idea here is, so you can chain these, like they've trained like these GPT models, right? Chat GPT, Grok, things like that. Um, and they're like crazy sophisticated, or at least they have a lot of parameters. Um, and it therefore takes a lot of processing power to train them and to run them, because it's just so much. They're just doing large or calculations with their this is what it is. They're doing calculations with large mathematical structures, and that is uh, processor intensive, and therefore energy intensive. Um, but they have to do those in order to get in order to sort of brute force um, a chatbot that can pass the Turing test. That's where we've gotten to. It's, I this hits me, periodically, a few times a week. Like, we live in a post Turing test world. When I was growing up, not even that long ago, even, um, you know, there was kind of I kind of had this anticipation, this excitement of like how close we were to passing the Turing test, and it's not in and of itself that big of a deal. It's one, sort of anecdotal measurement amongst more useful measurements, but it is one that's easy for lots of people to understand. And we sort of blew past it, kind of without fanfare. And I just sort of continue to be surprised by that. Like, I forget that, like, oh yeah, modern chatbots like are uh can modern chatbots pass the Turing test. Um anyway, in order to have gotten to this point, the models have to be the mathematical structures that are being utilized to create and that are themselves these models, um, have to be very large to accommodate sort of the complexity of human language, and because that's ultimately what these are doing, is they're sort of uh, these pre- these language predictive models based on what's come before, what is likely to come next, and they can content. I don't want to say contemplate. They can base that prediction on not just the most recent word or couple of words like your keyboard might do. Um, they can base it on thousands. I mean, I don't even know what the models are at now. Can they hold like more than a million tokens? Is that like their memory space or whatever? Um, so uh, so they have sort of this semantic ability, and that's a I think that's a big part of what allows them to pass the Turing test, is that, like, you can't older chatbots, they sort of knew how to mimic human speech patterns, but they didn't have any memory about, and they didn't like have the ability to have that memory be contextual. And now these chatbots can, simply by the amount of memory and compute we've brought to bear on them. Right? It is brute force. Um, and I'm wondering, what if you didn't need to capture the entirety of a human language? What if the space you were trying to make predictions in was smaller? Um, a little bit more regular or something. Um, and at a certain point, there's probably this like fine line about, well, if it's regular, um, and and if it's regular enough and the complexity is low enough, what's the use of an AI? There's actually probably just algorithmic solutions that would be better to handle interacting with that whatever that language. Um, and anyway, so I'm curious about playing with this, making small models that can make good predictions within a small and make and not necessarily GPT style. I don't know. I'm very curious about this. What happens when you shrink these models? Obviously, you shrink their capabilities, but there's still got to be applications for that, right? Um, and in fact, we haven't. We've been using this sort of machine learning. Like you remember Connect, Xbox Connect, uh, and lots of computer vision stuff, at least for a while, was built on sort of the same sort of machine learning neural network stuff. Um, I don't know what the state of machine vision is now. Um, so so I know we've seen just from the past that there are applications to less compute intensive versions of these machine learning and these artificial neural networks and things like that. We've used them for other things, and but understanding those can be a real base. I believe we'll see. I believe it can be a basis for understanding these larger AI systems and the sort of mathematics and therefore the technology of them. Um, so yeah, that's sort of where I would like to focus. Sort of the basics of linear algebra, trying to extend, seeing how quickly we can extend up to the uh, the type of the principles and the skills and stuff necessary to make the math we're talking about actually applicable to AI models. Um, in this is definitely going to be um, programming. We're not gonna do. There's no point to doing these calculations by hand. Um, to running an AI at the speed of hand calculations, right? Um, we'll probably do some hand calculations as like proofs of concept and to sort of show the underlying principles. But then I'm really excited to also then show, okay, now that we understand this principle, how do we really get some power out of it by programming a computer to do it at a much faster to do it much faster with larger mathematical structures. Um, and that's sort of that's the scaling power of computation, of computerized computation, of digital computation. There we go. Um, and that's what like these AI are taking advantage of, is just the fact that we can. There are individuals and companies now that have the resources necessary to build this infrastructure. So the issue here is that we don't get to collectively decide if that's what those resources should go to, right? And so the reason we're getting the type of AI, part of the reason we're getting the type of AI that we have right now, um, is because it's possible by just creating large enough data centers. And so what they're doing is creating these just massive warehouse, like multi-warehouse complexes of just data centers, just computers running. And the hope, it seems, is that if you can hook up enough computers, it will be complex enough to start to mimic, to start to be as complex as the human brain. But consider the difference of scale. Not that the difference of scale necessarily makes a difference for what they're trying to achieve, but like they're pouring all of these resources and they're consuming all this electricity and they're consuming all of this water, uh, consuming all of these chips. Nvidia's getting rich and rich and rich by making the processors, and so all of the resources that goes into making processors, it's a resource intensive endeavor. Um, all of those resources and all those resources to try to make something as as nearly complex as the human brain that can create what they're hoping will be some form of conscious being. They're trying to create a being out of nothing, which is sort of what happens with humans. Like this is, when a human is conceived, a consciousness is not instantly conceived. Our consciousness is emergent from the complexity of our brains. So that's what they're hoping for. They're hoping to just push the complexity to the levels where they finally get that emergence, and they're hoping they can control it. And they want to control. That's the whole point, right? We could also collectively, as a nation, say, yeah, that actually seems like a worthwhile endeavor, and we could collectively bring these resources to bear on it, and collectively through our electeds and through the freedoms and the responsibilities instilled in collective decision making, um, decide where our priorities are for it and decide how we want to scale, um, and decide that should something emerge from it, that's not a thing for any one person or even for any group of people to control or own. If they really are trying to produce a consciousness, um, that the desire for control is problematic. So let's learn the mathematics of AI, huh? Let's understand what they're trying to do, so that you can understand it's not actually that complicated. Uh, the the Musks and the Altmans of the world, um, they're not innovating. They're taking research and knowledge that we already had, but didn't have the technology and didn't have the concentration of wealth required to actually do this at scale. The theory behind all of this has been around for a super long time. Well, not like, I mean, relatively, um, for considerably longer than our ability to, to sort of brute force the computational power. So the only innovation at play here is they have innovatively concentrated their wealth, and now there's no oversight on what they're allowed to do with it. And so they've decided that they want to just pile up and connect together processors and hope that that if you simulate nearly as many neurons as a human has, well, then you'll get something that's nearly human. Um, and I don't disagree with that theory, honestly. All right. Um, Excuse me. Excuse me. All right, check this out. Oh. Oh. Okay. Well, I thought I was going to say check this out, but I thought it was something that was actually available to access, but it was not. Huh. Okay. What about this? So we have. This is probably going to be small on the stream. Hey, that's starting to look. Okay. Yeah, that looks like it might be all right. Okay. Mathematics of Artificial Intelligence. Gabriel Pere. Pierre. Um, This overview article highlights the critical role of mathematics in artificial intelligence, emphasizing that mathematics provides tools to better understand and enhance AI systems. Conversely, AI raises new problems and drives the development of new mathematics at the intersection of various fields. This article focuses on the application of analytical and probabilistic tools to model neural network architectures and better understand their optimization. Statistical questions, particularly the generalization capacity of these networks, are intentionally set aside, though they are of crucial importance. We also shed light on the evolution of ideas that have enabled significant advances in AI through architectures tailored to specific tasks, each echoing distinct mathematical techniques. The goal is to encourage more mathematicians to take an interest in and contribute to this exciting field. Hey, this seems like a place to maybe start or step like jump off from. Right? So like just empirical risk minimization and supervised learning. The objective is to, so I'm right here. The objective is to construct a function f theta of x dependent on parameters theta such that it approximates the data well. Yi is approximately f theta of xi. Uh, oh no. Something happened to the stream. It says excellent connection, but the stream isn't actually going. Oh, okay. I just refreshed. Okay, sorry about that, y'all. Back to this. Okay. In supervised learning, the objective. Oh yeah, sorry. The dominant paradigm involves finding the parameters theta by minimizing an empirical risk function defined as minimization of theta. Theta minimization e of theta is defined as this summation. Where L's loss function. Blah 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 blah. Okay, so there is a lot here, right? And so to even understand this, we would have to go through little pieces at a time and say, well, what does that mean? What does that mean? What does that mean? And then once we understand what those pieces mean, we come back to it and say, okay, now when we read this, what is this actually saying? Um, so yeah, this actually could be useful. Oh, I know. We can just do this. There it goes again. Are y'all seeing a black screen? Well, that's frustrating. If you're seeing a black screen, I do apologize. Um, nice. Okay. So oh wow, I did in fact paste this entire PDF in here. That's not actually what I meant to do. That's really funny. Um, I meant to just paste a link to it, but it is the entire PDF. Okay, we get rid of that. Okay. Uh-huh. Okay. So I can move it around this way. Can I make it? Okay. Well, that's a bit weird. Here, I should check for question submissions, huh? Okay. Well, now that I have this saved, and I'm happy about that. Oh, I have a feeling that's gonna probably bog down the Miro board. Oh, I can make it smaller. Oh, there we go. Oh, archive actions. Wow. Oh, excellent. This is actually what I was trying to do. Um, okay, I have some housekeeping stuff I need to do before the end of the stream. S2C. Yeah, so I am gonna I do a bit of that housekeeping stuff. I'll keep an eye on questions, but we're getting on down to the end of the stream here. And I do have a student after this. Um, Catalog. Okay. No, I do need it to be on this one. Okay, yeah, I did. Okay. that. All right, y'all. I think I am signing out of here. I'm gonna get myself going, get to my student. I will be back tomorrow after school, 3:30 to 5. So this Thursday will still be a regular time one, but we'll see. Going forward, I might decide to make that a night stream as well. I like the night streams. And having the Wednesday one be at 3:30 works because Wednesday's early release for local students at least. So yeah. I hope you all have a nice afternoon. It is rainy and it is dark out there. Hope you're cozy. Please, if you didn't have a chance to send a question in before the stream was over, please still send one in. I will address it tomorrow. Even if you can't catch it live, you can still watch the VOD and get your question answered. Hope you all have a great night. I'll see you tomorrow.